During this lesson, you will be required to fill out a worksheet. I recommend you read through the worksheet before viewing the lesson. In order to give you time to do this, you can use the pause button at the bottom of the screen. Building materials, mortar. Properties of general materials used in construction. Learning outcomes. By the end of this lesson, you should be able to 1. Give an example of where mortar is used in the construction of a building's fabric. 2. List the main components of mortar. And 3. Give a brief description of one characteristic of mortar. Mortar. When bricks and blocks are built, they need to be kept level and plumb, therefore truly horizontal and vertical. Mortar is used to help achieve this and to help bond the bricks or blocks together. Mortar is also used for forming screeds on some types of floors. Mortar can also be used for rendering or plastering buildings and walls in order to weather them and improve their appearance. Worksheet. Question 1. Give an example of where mortar is used in the construction of a building's fabric. The composition of mortar. Mortar is a mixture of cement or hydraulic lime, which is the matrix, water, which is the catalyst, aggregates, which are the fillers, and hydrated lime or plasticizer, which are added to the mix sometimes in order to improve workability. These are all mixed in controlled proportions. Two types of aggregate can be used, either soft sand or sharp sand, which we'll talk about in a little while. In the image on the top right hand side there, we can see an example of some mortar being mixed. All these components are mixed together dry first without adding the water. The water is the last thing that's added. All the other components are mixed together until they're all thoroughly mixed and all of the mixture is the same colour, and then we add the water and gradually mix it up. Worksheet. Question 2. List the main components of mortar. We're going to look at 5 common types of mortar now. The first one is cement, hydrated lime and sand. These are mixed at a ratio of 1:1:5. All these mortars also require water to be added, but the amounts of mortar can vary depending on the workability. This is a standard mix with good workability used on the superstructure of buildings. Superstructure of the building is anything above ground level. Substructure is anything below ground level. Just a note there, the hydrated lime that we use in this mix, this is made from soaked quicklime. Soaked quicklime is formed from just getting ordinary limestone and burning it at an extremely high temperature. We get soaked quicklime, and the hydrated lime is made from the soaked quicklime, and it's used in order to give workability to the mortar. And how it does this is by preventing the water from seeping from the mix once it's mixed up. Okay, and how it does this is the lime binds the sand together. So the hydrated lime is quite sticky once it's wet, and so what it does is it helps bind the sand particles together, which in turn helps hold on to the moisture to make the mortar more workable. The second type we're going to look at is cement and sand mixed at a ratio of 1:5. So the only difference between this and the previous mix is that there is no lime added to this. This is a durable mix used below the DPC damp proof course, in other words below ground level, and or above roof level, where there is a high content of moisture. Mixes below ground level and above roof level are usually quite strong at a mix of 1:3. The reason lime is not used in these mixes is because lime does not work very well in conditions of high moisture. In other words, underground, where there's going to be dampness and high levels of moisture all the time, or up above the roof. This third type then is cement, plasticizer and sand. Now this is again mixed at a ratio of 1:5. This is just the same as the first two mixes. The only difference is that we have plasticizer added to this mix of cement and sand instead of hydrated lime or instead of nothing. So mix number 2 there with cement and sand, we use that below ground and above roof level, but without any plasticizer or without any lime added to it, it would be very difficult to work with. So we add the plasticizer in order to give the mortar good workability. So this is a standard mix used on the substructure and superstructure of buildings with good workability. So in other words, this hasn't got lime in it, so it can be used below the ground, above roof level. It can be used anywhere, and this will be the most common mortar mix used these days. Note, what is plasticizer? Plasticizer is a liquid which is added to the water before mixing. So the water that we're using for mixing our mortar, we add the plasticizer to that. In order to know how much or what the ratio of plasticizer to water is, you can just read the instructions on the container. When churned up in the mixer, what this does, plasticizer does, is as the mortar is being mixed in the mixer, it creates millions of minute air bubbles which make the mortar more plastic and workable. The air bubbles also improve the thermal value of the mortar, but just ever so slightly. So it's quite similar really to washing up liquid. It creates kind of millions of tiny little air bubbles. Although you shouldn't use washing up liquid instead of plasticizer in your mix. So don't be tempted to do that. It can weaken the mix considerably. Number 4 there is hydraulic lime and sand. Usually mixed at a ratio of 1:3, quite strong. Hydraulic lime is the old mortar that used to be used, and it was overtaken by Portland cement about 50 years ago. So these days it's mostly used for restoration and preservation of old work. However, it is making a comeback with newer methods of eco-friendly building due to its high vapor exchange properties, which help avoid condensation. Ordinary Portland cement doesn't really allow vapor to pass through it. So when it's plastered onto a building or built in between bricks and blocks or stone, it doesn't allow moisture to pass through it very good. And this is good for keeping moisture out, but it doesn't allow vapor to pass through it. So it means if the building becomes damp and we've used Portland cement for building it or plastering it, means it doesn't really allow the building to dry out, whereas hydraulic lime has good vapor exchange properties, so it does allow the building to dry out during the summer. Hydraulic lime was invented over 2,000 years ago and widely used up until about 50 years ago. Hydraulic lime was overtaken by Portland cement mainly because it sets faster and it's stronger. It gets earlier strength than hydraulic lime. Hydraulic lime can only be used during summertime, during very dry conditions, and it takes a long time in order to get even initial levels of strength. Whereas Portland cement sets quite quickly and goes strong fairly quickly as well. Gets a good bit of strength after 24 hours, then slowly increases in strength after 7 days and then up to 28 days. Portland cement was invented about 175 years ago, and like I said, the main reason why it overtook from hydraulic lime is because it allows you to build much quicker and you can build all year round with it. The last type of mortar, number 5 there, is called trowel ready mortar. It comes in all colours and strengths, and it's delivered on site in a 1/3 cubic metre bag ready to build with. So it's pre-mixed in a factory. It's extensively used. It has been extensively used over the past 20 years or so, and it's suitable for most types of work. It's a retarded mortar, so it comes with a retarder added to it. So in other words, when it gets delivered onto site, you have up to 24 or 48 hours in order to actually use the mortar. The good thing about this is that it's not going off really quickly, so you don't have to be mixing on site. But the bad thing is that you can't build very high with it, and in damp conditions it takes even longer to start stiffening, starts getting initial hardness, and for strength as well. It takes a while to get its full strength. It's most suitable for brickwork or boundary walls. As the setting time is so long, it can slow down the work and create health and safety issues. But if you build a job, build a wall or whatever, and then a couple of days later you want to start putting the floor on top of the wall or putting beams on top of it, it mightn't be strong enough, or it mightn't have the mortar might not have gone off hard enough in order for it to support this after only a couple of days. We're just going to look briefly now at the two different types of sand that are used, two different types of aggregate that are used for mortar. We have soft sand and sharp sand. Soft sand, this is sand that is not washed, and therefore it still contains some bits of clay. It feels soft and smooth when you hold it in your hand, hence the term soft sand. When soft sand is used, it's also sometimes called builder's sand. So builder's sand would be soft sand. It's used for mortar, and when it's used for mixing mortar, it makes the mortar very smooth and plastic and easier to work with than if you're using sharp sand. It's much easier to spread when building bricks and blocks, and so really soft sand is only used for mixing mortar that's going to be used for building bricks and blocks and maybe stone. Sharp sand then on the other hand, this is just sand that is clean, it's been washed, and all the impurities have been washed out of it, or more specifically, all the clay, any clay particles have been washed out of it. It feels coarse in the hand, and hence the term sharp. These terms are used by bricklayers and plasterers, and sharp sand, which is also called plastering sand, is used for rendering on walls, floor screeds, and for paving. We would never use soft sand for paving. We only use sharp sand for paving. Sharp sand allows good drainage for water when used under paving. If we used soft builder sand for laying down paving slabs or bricks, what would happen is once it rains, there wouldn't be very good drainage in the soft sand, and our paving would start rising up and would end up kind of floating on top of the very wet soft sand. So for paving we only use sharp sand. Again, for plastering we only use sharp sand. Mixing and batching. Mixing can be achieved through volume batching, which is most commonly used on site using a shovel or a bucket, or weight batching, most commonly used in factories, so that would be for the trowel ready mortar. Water is added depending upon the workability requirements. So for example, if you're building stone, you wouldn't add much water to your mix because you want it to be fairly stiff in order to support the heavy weight of the stone. With blocks then, they're quite heavy as well, so you wouldn't want the mix to be too wet. And then for bricks, again, you want a decent amount of water added when you're building bricks, because bricks can suck the moisture out of the mortar quite quickly. Worksheet question 3. Give a brief description of one characteristic of mortar. Here's a link to that one article that I mentioned earlier on, just on hydraulic lime. If you want to take a note of that, you can look it up and read more about it. Summary. In this lesson you covered properties of general materials used in construction, including mortar, used for building bricks, blocks and plastering, also used sometimes for floor screeds. Main components of mortar are cement, soft or sharp sand and water, and sometimes lime or hydrated lime or plasticizer is added to improve workability. Different types of mortar can be used depending on your requirements. So for example, strength, workability, location, in other words, are you building under the ground, above the ground, are you building in very wet conditions, in drier conditions, and also the materials being built, are they very heavy, are they light, do they have high absorption rate, different things like that.